Hey folks, I hope you are doing good. Um, welcome to my channel. Today we will be going today in this video I will try to explain how we can tune Go pprof. So pprof is Golang's profiling tool, which comes by default with it. So in this video we will try to tune the pprof so that we can catch real bottlenecks. We will start with default settings, see their limitations, and then tune CPU, memory, block, and mutex profiling to get sharper signals. Uh, so this is a demo code that I have written for this video. For this video. So I will give a short walkthrough of this, what it is doing. So generally there are three functions here. So let's focus on only these two functions because this hot calc function is being called by CPU burn. So what the CPU burn is doing is that it is simulating a CPU hotspot. It does math in tight loop, then sleeps for 50 milliseconds. This is like a service. We can consider it like a service that bursts with work and then idles briefly. Leak simulating the memory leak. Every 10 milliseconds we are allocating 64 KB and hold on to it. We are not since we are allocating it in the slice, and we are not basically we are running this for loop, so garbage collector will not be deallocating the memory which is being allocated here. So it will grow over time. This heap will grow over time. So let's try to run this with a default setting. So now I'm running the service with default pprof setting. By default, Go does CPU profiling at approximate 100 samples per second, and only sample memory allocation every 512 KB, and mutex and block profiling are off by default. So let's try to run the CPU profiling. So pprof, what happens is that whenever pprof expose these HTTP endpoints, different HTTP endpoints for different profiling, like this is this is for the CPU profiling, and then there is a different endpoint for memory profiling, then different for mutex, and same goes with other profiler that pprof supports. Now let's try to see. So here's the CPU profile with default. Here's the CPU profile with defaults. Notice that CPU burn is at top, but attrition may look noisy on short bursts. So with 100 samples per second, small spike can be missed. So if you are only collecting 100 samples per second, it might be the case when there is a short spikes, we are completely missing that. So that's CPU. Let's try to run the memory as well. So here's the heap profile. Our leak is allocating 64 KB at a time, but the default sampling rate is 512 KB. That means it might miss some of these smaller allocations, so visibility into small leaks is limited. Let's also try showing the flame graph. So again, it will run the pprof for 15 seconds. Flame graphs are a better way to visualize. So let it try to open the flame graph once, and I will show you how you can read it also. So by default, it is showing this graph representation. I don't know where it goes, but let's switch to flame graph. If you see that there are different boxes here, so how to read them is that white boxes means more CPU time here. Here CPU burn is clearly white, but remember this is 100 samples per seconds. So it is good enough sometimes. I'm not saying like the default is bad all the times. It is good enough sometimes, but not very sharp. So as I said, that it might miss small burst that we are seeing in our production system. Now what we will do is we will enable the tuning. We will tune the pprof. So I will explain each of these things. So what we are doing here is that first thing we are doing is we are increasing the sample rate from 100 to 500. This will enable us to capture more samples, and will have so that we might be able to capture more cases where there is a short burst. And we also decreasing or basically decreasing the allocation that it tracks from 512 kb to 64 kb, so that we also capture the or we are able to track the small leaks as well. By default, block and mutex profiles are off. By setting this to 1, we are enabling the block and mutex profiling as well. Let's rerun our code. So again, the same command we have fired here to run the CPU profiling. So let's see. So now we are collecting more samples. The CPU hotspot is much sharper. Generally, whenever we are changing this, right, since this is not running in the production system, so we are not able to show right now that what is the significance of changing this from the default 100 to 500. But in the production, when there is a short bus, it is really helpful to capture these cases where there are short bursts, so that we collect more samples, and we are able to see where we are seeing more where we are seeing basically this CPU burn, right? So yeah, let's also try to see on the mutex part and the block part. So generally is nothing. Yeah. So block and mutex profile are empty by default, as I mentioned before. Now that we are enabled them, if go routine install on channels or logs, they show up here. But in this app, they are quiet. But in real service, these profile real contention hotspots. So again, if you want to see the flame graph, we can see it like we did in the previous default settings. So now to wrap it up, so that is the Go pprof tuning. Default is simple but limited. So it's not like that default is default might not be I'm not saying that the default might not be capturing anything. So default is powerful, but there are certain cases in production which require us to tune the pprof. So that we can capture the small leaks and these small bursts that can be invisible sometime when there is when we are using default pprof itself. So when we are tuning this pprof, we are increasing the sample rate and lowering the memory threshold, and we are also enabling the block and the mutex profiling, so which is making our leaks and hotspot more obvious. Generally, it is recommended that we should tune these things or play around with these things in local. We should not try to do this in production. If we are doing this in production, it should be behind some environment variable, so that we enable that variable for a short amount of time and then disable it once we get some samples to analyze where our code is not working correctly. Or we can try to replicate or simulate the same production system and play around with it by basically increasing the load of the system with some load testing tool. So yeah, that's it. That's about today we explored about how we can tune pprof. There is a lot of more things about it, so you can read more on this here, which is basically this Golang documentation. So yeah, thank you guys.